Okay, for this problem we want to find the area of the indicated region under the standard normal curve. You're going to need to use Table 4 from your textbook. Sometimes the problems will have links that allow you to open the standard normal table. Other times you will have to actually use the table from the book. I have incorporated a handout in Blackboard that has a PDF of the tables that you're going to use for this particular course. Now what you're going to notice here is that they've already given you a diagram, and they want you to find the area that occurs between z equals 0 and z equals 1.2. Remembering that z equals 0 is going to have an area underneath this curve, which is going to be right here, and that's going to be to the left of that particular line. And if we have z equals 1.2, that's going to be the area under the curve that goes all the way like this, and that's going to include all of this, and that will be to the left of that line. So what I need to do is find the area under the curve for z equals 0 and z equals 1.2. By definition, z equals 0 has an area under the curve or a probability equal to 0.5. That's because half of the curve falls to the left of z equals 0 and half of the curve falls to the right of z equals 0. Keeping in mind that we're going to have to go into the table over here and look for a z-score of 1.2, which means we come to the z column and we're going to come down to 1.2, and since this is 1.200, we're going to go ahead and look at this number right here, 0.8849, which means that for a z-score of 1.2, the probability or area is going to be 0.8849. Now, in order to go ahead and find the area that's in between these curves, we need to understand that it's going to require us to subtract z equals 1.2, or I should say subtract from z equals 1.2 z equals 0.0. In other words, the area under the curve that is between z equals 0.0 and z equals 1.2 will simply be this. The area will be equal to 0.8849, which is the equivalent area or probability under the curve for z equals 1.2, and we will subtract from that 0.500, which is the equivalent area or probability under the curve for z equals 0. Once we do that subtraction, we find that we have 0.3849. That is going to represent the area under the curve between those two z values.